For our next level of analysis
Good morning,
of
sir.
quantum mechanics in a spherical polar coordinate. So we have learned what is the meaning of theta and phi. Now we will talk about what are the radial part. So obviously you know that there is three variable into a spherical polar coordinate, r, theta and phi. First we have gone for phi, then theta, and now we will just go for r, radial part. But in our course mainly we have to work with central force type of problem. Means potential is only function of r, and we have also seen what are the property of central force into classical mechanics. So physics will remain same, but the approach is going to change. So for the central force problem, what you will get Hamiltonian, and this Hamiltonian is nothing but the kinetic energy plus potential energy, and you will find that L square and H is going to commute. Why I am making this assumption that H and L square is going to commute? What is the reason behind that? The reason behind that is very simple. Because for the central force problem, external torque is zero, so angular momentum is conserved. So whenever anything is conserved, it is bound to conserve with Hamiltonian. So for the central force problem, this is going to conserve. So what is meaning of that? Meaning of that, the eigenfunction of L square will be also eigenfunction of Hamiltonian, and vice versa is also correct. So what is the eigenfunction of L square? We have find in the last 2 or 3 classes. The eigenvalue of L square will be, you know that L square will operate YLM theta phi is equal to L into L plus 1 h cut square YLM theta phi. So this is the whole story. And this is the concept, and we will take the we have enough opportunity to use our mathematics, and to simplify our mathematics using this concept, and you will find that this is one of the wonderful thing. So let's try to find how we will approach the completely for the spherical polar coordinate if the potential is central force. So I always say this potential is something like central force. So let's try to figure it out how we will go for this. So obviously we have to calculate h psi is equal to e psi, and h is nothing but minus h cut square 2m del square psi is equal to e psi. And this psi is a function of r, theta, and phi. Psi is a function of r, theta, and phi. Now, what is this del square? This del square is nothing but the Laplacian in a spherical polar coordinate system. So what I have to do, I have to use this Laplacian to solve this differential equation. So let's go for what are the complete equation. So I need a lot of space to solve this type of problem. So I am removing all this thing. So obviously the solution is minus h cut square upon 2m, and for the del square what we have basically Laplacian into a spherical polar coordinate, and if you remember, this thing will be 1 upon r square del upon del r square del square psi upon del r square plus 1 upon r square sine theta del upon del theta sine theta del upon del theta, and we can put psi here, plus you have 1 upon r square sine square theta del square psi del phi square. This is your kinetic energy plus potential energy. VR psi is equal to E psi. Okay. So this is the total kinetic energy. Okay. This is kinetic energy. And in this kinetic energy, we have translation kinetic
Sir,
energy.
isn't
We
the
have
first
rotational.
term del phi by del r? So the first term isn't it del phi by del r?
What del phi by del r?
So how is it del square phi by del r square?
I don't
सर
think this
सर
is the Laplacian.
सर फर्स्ट टर्म डेल अपन डेल आई स्क्वायर आएगा ना सर
Sorry,
So
del
double
r.
derivative नहीं करें.
Del r. Sorry. Del r. Okay. Sorry. Double लिख दिया था. Okay. This is the del psi upon del r. Okay.
ये आर स्क्वायर होगा
Now, कहाँ पर r square होगा?
डेल अपन डेल आर स्क्वायर सर
This one?
ओके ठीक है सर
Okay.
No.
सही है
It's
सर.
okay. सही है. ठीक है. Okay. आप इसको ओपन करोगे तो होगा. अभी कर रहा है, ओपन कर रहा है. Don't worry. And now, if you will see the whole thing very carefully, look at. I am writing this thing very carefully. That will be minus h cut square 2m. This will be 1 upon r square del upon del r square del psi upon del r. And here I am writing minus h cut square upon 2m r square. Just I am writing this angular together 2m r square. And you are taking the whole thing inside this particular bracket. That will be sine theta del upon del theta sine theta del psi upon del theta plus 1 upon sine square theta del square psi del phi square plus VR is equal to ER, E psi. And here is psi also. Now, if you will see this whole story, look at, I am just clubbing this all thing. Can you recognize this all operator?
एल स्क्वायर सर
L square operator. We have done in the last class. Okay. So we have recognized this thing is nothing but the L square operator. So what I can do, minus h cut square upon 2m 1 upon r square del upon del r square del psi upon del r plus L square upon 2m r square psi plus VR is equal to E psi, because I have written this term as operator L square. And now, hence, H is going to commute with L square. I can write this psi r theta phi as radial function RR y lm theta phi. Can I write this thing? Because due to this potential is only function of R, we can just write this particular thing. Can I write this thing?
Yes, sir.
Yes, because, and this is your radial part. So I am interested into this radial part. I know this, what will be this thing. In any problem, in any central force problem, this will be the automatically eigenfunction. Automatically, because angular momentum is conserved, then y lm theta phi is always eigenfunction. What I am concerned about this radial part. So let's try to put this equation, this r y lm theta phi into this equation, and let's see what is going to happen. So I am removing this part. So what will happen? This will be minus h cut square 2m. This is partial with respect to r. So YLM will be treated as a constant. So YLM will be treated as a constant. And this whole thing is nothing 1 upon r square d upon dr r square dr upon dr, and this is only radial part. And now in this equation, the L square will operate on psi r theta phi, but it will operate on YLM. What it will give? It will give you L
L
into
equal
L plus 1
H cut
h cut square upon 2 mr square, and that will be radial part will remain same, and you have y lm theta phi. And v will be only operate on the radial part. This will be treated as constant. So you have vr radial part r y lm theta phi is equal to e radial part y lm theta phi. So this is the thing. And now what we will do, we will just equate the ylm both side, and we will get only the radial part equation. So I am removing this part also, and finally I will get only equation which will responsible for r. So what we have, minus h cut square upon 2m 1 upon r square d upon dr r square dr upon dr plus L into L plus 1 upon 2mr square h cut square also plus Vr. This will be radial part Rr is equal to E radial part. So now this equation is all about the radial part. So I can further do the calculation. And this you can just do this thing at once, and after then there is no need to do this particular thing. We will just start from basically where this is useful. Now we can just go for this. So this will be minus h cut square upon 2m. This will be d square r upon dr square plus 2 upon r dr upon dr plus you have L into L plus 1 h cut square 2mr square plus potential energy Vr is equal to Rr is equal to Er. So this is all about the differential equation we have to solve. And during the solving this particular differential equation, let me give you all this concept. What are all these things? So this is the potential energy. What is this energy? Can you recognize this type of energy? So here you have three type of energy. One is potential energy and kinetic energy. But kinetic energy will we have two different mode. One is translation kinetic energy and another is rotational kinetic energy. So this is nothing but the rotational kinetic energy. This is potential energy. And obviously this is nothing but the translation kinetic energy. You remember in a classical mechanics, we have defined V effective. What are V effective? V effective is rotational kinetic energy plus potential energy. So here in a quantum mechanics, we have also V effective. This is rotational kinetic energy plus potential energy. So whatever be the nature of potential, that will be only solved by the V effective. And you can see the translation kinetic energy plus V effective is equal to total energy. And this is your translation kinetic energy. So always keep in mind that translation kinetic energy is not this one. Translation kinetic energy d square r upon dr is plus 2 upon r d upon dr. So what is translation kinetic energy operator? Translation kinetic energy operator is minus h cut square upon 2m d square upon d square r plus 2 upon d upon dr. This is the new operator you can find, and this is the translation kinetic energy. Always keep in mind the most important concept. But how you will solve this thing? So this is very difficult to solve. So we will play a trick. So we will go for the further substitution on this particular thing, and we can easily find out what is the next trick. So what you will do, you will just try to do this with yourself. So I am removing this thing. So you will just put a new variable r is equal to ur by r. Remember, even in into central force problem, we are using this type of substitution. You can remember. So if you will put it this equation, then this will be minus h cut square upon 2m, and this will be d square u upon dr square, and then you can get, you have very simple simplified this thing, plus L into L plus 1 2 mr square h cut square plus vr ur is equal to e ur. Now, if you will solve this differential equation, and obviously the solution of this differential equation is very difficult once you will get the different type of potential. But yes, theoretically, you have to start always from this point. So you will start from this point, you will get the radial part, y, l, m, theta, you know, you can get the answer. So theoretically, you can do this thing. Up to that, if you have any doubt, you can just ask me. You can easily do this thing. Just put it here and you will get this answer. This is mathematics. Here is all physics we have. So let us go for next level of understanding of this radial part of wave function. Are you getting everything? So in the examination, you have to start from here. Even you have to just go for the final result, whatever we are doing, because you have objective exam. But yes, how you will get this thing, this is very important. Now, here is the most important concept. What you have, look at. You have wave function psi r theta phi is nothing but the radial part of wave function, and y l m theta phi. Okay. What will be the normalization thing? Normalization thing is psi star r theta phi psi r theta phi 0 to 2 pi for phi, 0 to pi for theta, 0 to infinity for r. And what will be this thing? This thing is r square dr sine theta d theta d phi must be equal to 1. Okay, must be equal to 1. This is your normalization constant. Now what we will do, we will just put the radial part and y lm theta phi. Then what will happen? Look at here. You have mod r square dr. I am just collecting the r term 0 to infinity, and you have y l m mod square sine theta d theta d phi 0 to pi 0 to 2 pi. This will equal to 1. Can you remember what is this value? What is this integration?
1.
1. This integration is 1. So this integration is 1. So obviously, right hand side is 1. This integration is 1. Then it must be 1. Isn't it? This integration must be equal to 1. So 0 to infinity mod r square dr must be equal to 1. And here we are going to define the radial probability density. So if radial wave function, so are you getting this thing up to this mark? So let's try to define radial probability density. So if R is the radial wave function, then radial probability density rho r is basically mod r square into r square. Please. So this is the definition of radial probability density. Lot of people are doing the conceptual blunder that they are just taking the mod r square. No, only mod r square is not radial probability density. Mod r square into r square is the radial probability density. Are you getting this thing? It's a very clear cut message. Please, mod square into r square is the radial probability density. You don't, even if this is r is the radial wave function. And your radial part of wave function is also normalized, angular part of wave function is also normalized, and total wave function is also normalized. So you have to always keep in mind all this concept. And if you understand all this concept, then we can go for next level of calculation. And yes, in the examination, you have to always keep on focus whether they are giving you the radial wave function or total wave function. Because if they will give the total wave function, means they are giving you that particular YLM part is also included into calculation. For example, just tell me, if I want to calculate expectation value of R, then only radial wave function is enough, or total wave function is enough, or both can be used? Just tell me answer. Because I am just, both can be used. Okay. So you can easily see. So please always keep in mind, because I am very much concerned about your blunder concept into your exam. Okay. So if you are going to calculate radial part of wave function, it can be written as psi star r psi r square sine theta d phi. And this will be also equal to radial part r star r r r square d theta. So you can use the same thing. If you can use the total wave function also, you can use the radial wave function also. You will get the same answer. Now, if I just want to calculate expectation value of x. So what is expectation value of x? How you will calculate? You will just write r sine theta cos phi, isn't it? Then which one is useful? The total is useful or radial is useful, or both are useful?
Total.
Only total are useful, then radial part will not work. So you have to always keep in mind that which wave function you can use. So this can be only figure it out with the function that is total wave function. Psi star r sine theta cos phi, this is your x, and psi, and you have r square sine theta dr d theta d phi. Here dr I have missed. Okay. So you have r square dr. Okay. So you can have. So when the variable is theta and phi, then only total is used. But when variable is r, either you can use radial or total. You have to take concept. But when you are using the total, the sine theta d phi must be included into calculation. This thing is most important thing in the calculation part of all this particular topic. So I am giving you extra advice. So how you will go for this problem. Okay, so let's straightforward go for application of whatever we have done, such that we can clear all our concept. So today I will do one application, and tomorrow I will straightforward go to hydrogen atom. So I think you understand all this concept. If you have any doubt, you can just ask me. Are you agreed?
Yes, sir.
Okay. So let's go for one beautiful problem. Then, and this is a very nice problem. And this type of problem can come into your exam. And in fact, it has once came into your exam. So what is the potential? The potential VR is given as 0 if R is less than A, infinity R is greater than A. So this is some spherical box. The particle is bound inside this box. Okay. So this is the spherical box. We will do this type of problem in scattering also. But this is something called a spherical box. The particle is inside this box. We have to just figure it out. Find psi r theta phi and energy for L is equal to 0. So I am just talking about a spherical wave. L is equal to 0 because if L is there, it will very complicated and we will do it into a scattering part. When scattering will come into picture, but I am just going for straightforward for L is equal to 0. So from where you will start this problem? Just you will start this problem minus h cut square upon 2m d square u upon dr square plus this will be plus L into L plus 1 h cut square upon 2mr square plus Vr, and this will be Ur is equal to EUR. So you will start from here. And you know that potential is infinite, then wave function is 0. So U is equal to 0, even R is 0. So you have not bothered about this. So inside this, your potential is 0, and I have to solve for L is equal to 0. So the solution is very simple. Minus h cut square upon 2m d square u upon dr square must be equal to EUR. And what will be solution? The solution is d square u upon dr square plus 2me upon h cut square ur is equal to 0. So I can put this thing as k square. Remember? So this is exactly, you can get the answer. D square u dr square plus k square ur is equal to 0. What will be solution? What will be solution? The solution is e to the power ikr plus e to the power minus ikr. Ur is equal to a e to the power ikr plus b e to the power minus ikr. Isn't it? And we have used boundary condition. So you cannot go beyond t is negative. So you can
Sir,
assume, yes. Are you getting
sir,
this thing?
sir, is V effective 0 or V of R 0?
V effective itself is 0 because I have chosen for L is equal to 0. Okay.
Okay.
I am solving for the L is equal to 0 for the spherical waves only. And potential is it also 0 inside this box. The potential is 0. So all B effective is 0. Are you getting this
Okay,
thing?
sir. Yes,
Huh.
sir.
Because if I will put L, then this will be very complicated. And I promise you, I will solve it that for also. But in the scattering. So just let's see what will happen this thing. So obviously at R is equal to 0, UR must be equal to 0. Because you cannot go beyond that. Negative R is not allowed. So negative R is not allowed means you can assume that there is some infinite kind of potential, some sort of this. And mathematically, if R is not allowed, then you have only this option, not other than this. So what will happen? A is equal to minus B. So UR is equal to some C sine KR. So this sort of solution is there, but I am interested into radial part. So radial part r is equal to obviously ur by r, that will be c sine kr upon r. So this is your radial wave function. And now let's go for another boundary condition. What will be another boundary condition? At r is equal to a, again radial part must be 0. So ra, you have c sine ka by a must be equal to 0, means ka is equal to n pi. And what is value of n? 1, 2, 3. And from here you can get the value of k, and itself you can say they are quantized. And inside k you have energy. So 2m e upon h ket square is n pi upon e. So you can get en is equal to n square pi square h ket square upon 2m a square. What is value of n? Is equal to 1, 2, 3, and so on. Simple, just like a particle in box. Let's try to figure it out. What will be value of c? What will be value of c? So radial part must be normalized. So if radial part is normalized, what will be normalization condition? Remember, 0 to infinity mod r square dr must be equal to 1. So this is the radial part, the normalization of radial part. So just put it this particular value, c square sine square n pi r upon a, and here is r square dr. You will just go to 0 to a, because otherwise it is 0. So this r square is gone. Can you get the value of c? What will be answer? Please give me, because we have done this type of problem.
Root 2 by a.
Root 2 by a.
Root 2 by a.
Simple. C is equal to nothing but root 2 by a. Simple. So what is your radial wave function? The radial wave function Rn, and this will be radial wave function is root 2 by a sine n pi r upon a by r when r is less than 0, less than a, and this will be 0 if r is greater than a. That's it. Even you can use this particular thing because it is continuous. So this is the radial wave function. And what will be total wave function? What will be total wave function? Psi n 0 0. Because L is equal to 0, then M is equal to also 0. So this will be radial wave function Rn and y 0 0, isn't it? And what is radial wave function? The radial wave function is again 2 by a sine n pi r upon a by r. And what is y 0 0? Remember what is y 0 0?
1.4 pi.
Root 4 pi. That's it. That will be r is less than a, and 0 r is greater than a. That's it. So, and what will be energy eigenvalue? So I can write it in complete form. So your psi n 0 0 is equal to, you can just put 4 pi there. What you will get? 1 upon root under 2 pi a sine n pi r upon a by r if r is less than 0 and 0, sorry, r is less than a and 0 r is greater than a. And what is your e n 0 0? That will be n square pi square h cut square 2ma square, where n is equal to 1, 2, 3, and so on. So this will be n0, 0. L is equal to 0 and m is equal to 0. So this is the wave function. You can easily figure it out. So what will be, which kind of wave function is there? Sinusoidal, but exponentially it is decreasing, isn't it? You can have this kind of wave function. R tends to 0. So then this is 1 and it is exponentially, it is decreasing, isn't it? And at a is equal to, it is 0. Something this kind of wave function is there, isn't it? This kind of wave function is there. And what energy eigenvalue? You will be mesmerized. This is three-dimensional system, but it is a spherical system. What is the energy? What is the minimum energy eigenvalue? That will be E1 0 0. That will be pi square h cut square upon 2ma square, exactly for the one-dimensional box. In 1 year, they will ask the question, what will be energy associated to this spherical box? And they have deliberately written that a three-dimensional spherical box, what will be energy eigenvalue? The most of the people have put 3 pi square h cut square upon 2m square. No, this is not the answer. The energy is only associated to the radial part. So if energy is only associated to the radial part, there is only 1 degree of freedom is associated to the energy. For L is equal to 0 actually. For L is equal to 0. So the effect of centrifugal part will be gone and only translation kinetic energy is there, and that will be equivalent to particle in box for 1 degree of freedom. That is exactly pi n square pi square h cut square upon 2ma square. Are you getting this thing?
Yes, sir.
Yes, sir.
So this is one of the wonderful problem you have to always keep in mind. Now, please tell me what will be expectation value of x and expectation value of x on psi NLM. The expectation value of r and expectation value of x. What will be this particular thing? So obviously for r you can take either radial part or total. I am taking total. You can just verify with the radial part also. So expectation value of r is psi star r psi r square dr sine theta d theta d phi. So this will be written as 1 upon 2 pi a, and here you have wave function sine square n pi r upon a r square dr 0 to a, and you have sine theta d phi 0 to pi 0 to 2 pi. Now this r square is cancelled, and this thing, what will be this integration? Can you tell me? You have done this thing lot of time. What will be this integration?
4.
4 pi.
4 pi, not 4 pi. Okay. So this integration is 4 pi. So 4 pi upon root under 2 pi a, and here we have sine square n pi r upon a dr, that is 0 to infinity. So this will be root under 2 upon a, and r is also there. Sorry, one r is missing. So r is also there. So this will be 2 and sorry 1 minute 1 psi square. So this will be whole square. This will be whole square. So this will be, I think, 2 upon a, and you have integration r sine square n pi r upon a dr 0 to a. Can you please tell me what will be this value?
A by 2, sir.
A by 2. Exactly a by 2. So मुझे कुछ इंटीग्रेट नहीं करना पड़ रहा है. I am just using the concept and I am getting the answer. If you remember one dimensional thing, you are using it again and again into two dimensional, three dimensional everywhere. This will be a by 2. Now, what will be expectation value of x? So let's go for expectation value of x. And yes, you can verify it with the radial part also. Just try to verify it from radial part, you will get the same answer. So expectation value of x, we are just going for this, is again psi star x psi, but x is here r sine theta, r sine theta cos phi psi, and you have to just go for d square dr sine theta d theta d phi. Okay, so let's go for this. What will happen? You have 1 upon 2 pi a, because both psi will give you square term, and here you have sine square n pi r upon a by r square, and r square and 1 r is there, so there is 1 r dr, and this is 0 to a, and another integration is all of the angular part. So what will be angular part? R square, this is sine square theta, na? Sorry, this will be sine square theta. Sorry, r square sine theta, isn't it? So this will be sine square theta d theta 0 to pi, and another is cos phi d phi 0 to 2 pi. Now, what will be this integration?
The last term 0 है sir.
Last term 0. This will be 0. So there is no need to do anything. There is no need to do anything. So this term is 0. So everything is 0. So expectation value of x will be 0. ये सब अभी एग्जाम में आया नहीं है, so be prepared for all this thing. How you will just approach all kind of thing. Okay. So this is the thing, you can just try to do this thing. I will suggest just go and figure it out. What is expectation value of r square? What is expectation value of z? And all this thing. Just try to figure it out. How you will get all this thing. So the method is same. So I hope you remember, you just understand how we will approach the problem. And tomorrow is the main thing we have to do, that we will just go for the hydrogen atom and we will try to solve each and everything for hydrogen atom. I will not go unnecessary derivation, but I will just give you concept and then we will apply all this concept of hydrogen atom. So from this is relatively very simple problem. So you understand what is the concept behind all this thing. And tomorrow we will just try to, in the next class, to use this thing for the hydrogen atom. And you will see that will be very interesting. So tomorrow we will finish hydrogen atom. Up to that, if you have any doubt, you can just ask me. And please revise your gamma integral, because tomorrow it will be used very frequently. At least in every problem you have to use gamma integral. So please just revise gamma integral, and then next 50 to 60 minutes we will just finish this hydrogen atom. So that means we are just going to finish the second level of also calculation, and then we will go for the finally uses. Whatever we have learned, we will use it again and again for different type of calculation, from the classical mechanics to quantum mechanics. Each and everything we will use again and again and again. So next 5, 7, 6 class, whatever be the required. Okay, so if you have any doubt, you can just ask me. Are you getting it or not?
Yes, sir.
Because it is, for me, it is very difficult to solve each thing and everything into one board. So just try to do this integration again and again, all this calculation. And if you have any doubt, you can just ask me.
Yes, sir.
Okay. Okay, so I am leaving this session.
Yes, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.